Sawadee Krap, Pomchu Yoshihiro, Kirishima, NJS. Today, I'm going to talk about the latest status for DHS technology. DHS, downflow hanging sponge, is originally developed to treat effluent from UASB since 1995 in Japan. This technology is very similar to trickling filter, and there is no need of external aeration. Therefore, as you can see this energy consumption graph, we can save the power of the treatment about 90% less compared to the conventional activator sludge process. Sludge can be maintained not only the surface, but also inside of the sponge. This causes very high concentration of sludge, longer SRT and short HRT available, which means the compactness, and also it is very easy to maintain the plant. The right below photo is the biggest DHS plant in Agra, India. There are several real-scale DHS plants in the world already. The latest one is about 30 cubic meter per day capacity in Kota Kinabalu, Malaysia, and just finished the construction. We experienced many difficulties for the construction in overseas in the past projects. So we applied the box unit type to minimize the construction worker site. We first utilized this type in Sasaki, Japan, and we installed this type in Khon Kaen, Thailand as well. Through this project, we found it is much easier to build the plant compared to original type of DHS. This is the actual construction status of 100 cubic meter per day capacity pilot plant. For example, 2 days for foundation arrangement, 1 day for installation of primary sedimentation and DHS reactor, 6 days for pipe works, 3 days for electrical cabling and panel setting, and 2 days for test run. We completed all the site construction work only in 14 days. We installed a submersible pump in the existing pump pit, then pump up to primary sedimentation tank. The effluent from primary sedimentation tank flows into DHS by gravity and treated by attached microorganisms. This is upper stage of DHS reactor, and this is the lower stage. These photos are 3 months after the operation. Treated effluent is once accumulated in the bottom tank and discharged to the river. A little ventilation system is installed at the bottom of DHS. Then the odor from primary sedimentation and top part of DHS is deodorized by biological treatment of DHS itself. If you focus on BOD, SS, and ammonia, the effluent are all stable under condition of HRT 1 hour. However, phosphorus cannot be removed by DHS. If you want to remove the phosphorus, you need an additional facility. This system can also reduce the space of facility. This will help effective land use. For example, in case of aerated lagoon, we could reduce 95% of land space. In case of conventional activator sludge process, we assume about 50% saving of land space. We have received good reviews on that project, and we have finished preparing for the draft DHS technical guideline in Japanese and Thai. The English version of DHS technical guideline is also ready to easily spread DHS technology in the world. Please visit this YouTube link. This is the latest DHS plant 3D image and actual photo in Kota Kinabalu, Malaysia. We just successfully completed construction 100% by remote without travel of Japanese expert and the COVID-19 pandemic. Buffer tank and USB were manufactured in Kota Kinabalu, and DHS was shipped from the factory of a Japanese company. We applied container type for this project, and this can be treated high concentration and high flow fluctuation switch. That's all for my presentation today. Please feel free to contact us for the latest status or any requests related to the DHS system. You can also contact us through our business partner, Mr. Prampon in MK Water Tech in Thai. Thank you for your kind attention.